Hello students, it's Mrs. Cinti here, and welcome to math class online. So I want to just talk to you about this last section in our chapter 6 notes, graphing systems of linear equations. I want to remind you of some things and help you to move through them. For this, we are not necessarily going to be graphing on your papers. You're going to be graphing, actually, you're showing me that you know how to graph, and so let's go ahead and use our, mathway.com to check your answers, okay? So let's go ahead and just discuss all the things you know about graphing linear inequalities. I don't think I put that in the first slide, did I? So linear, so this should have actually said graph systems of linear inequalities, okay? So let's look at some of these, okay? So first thing to remember that we need to remember is we need to remember our shading, okay? So please remember shading, okay? So one thing that you need to do, so remember shading, meaning that when we have a graph and you have a line here, right, you need to shade on this side, or you need to shade on this side, depending, right? But in order to figure out what side to shade on, we need to move all of our equations. So we need to rearrange equations into our y equals mx plus b, okay, which is also known as the slope-intercept form, okay? So move them all into this, and then you can look at your nice generic y is, if it's greater than the mx plus b, then you always shade above the line. Here, I'd like to get crazy with the colors. Please shade above the line. And in this case, the dotted line, dotted line, because of this thing right here. If it was y is greater than or equal to mx plus b, then you would shade above the solid line, okay? The reason why is because if it's greater than, that means that it doesn't include what y is. This one does include what y is. So whatever the line is resting on, you would be shading there. So just to give you a nice look at notes, here, if this is your line, you're going to be shading above. Oops. If this is your line, because of course it should be dotted. If this is your line, then you're shading above the line. If this is your solid line, because there's a because it's greater than or equal to, you have the you're shading all of that. Okay, and then on the flip side of that, flip side, right? If y is less than or equal to mx plus b, you will shade below. And the same goes with this, shade below, but please remember, of course, your dotted lines versus solid lines. So here we would have, let's make this a nice solid line. Let's make this a nice dotted line. Look how nice that line is. And then you would, of course, shade below the line. Shade below the line. Okay, so so very colorful way to remind you of all of those things. Also, another thing that I would love to remind you about is that dotted line, any point on the line is not a solution, we said. And then also, please remember that when you are, let's say it's negative 2y is greater than, I don't know, 4, right? If you are dividing by, to simplify, if you have to divide by a negative, okay, anytime you divide or multiply by a negative, what do you have to do? What do you have to do? You have to flip the sign. So if you're doing that, you cancel that out, that's great. but now suddenly your answer, y is no longer greater than, it is now less than -2. So just remember, you're going to have to solve again to get to the slope-intercept form. And so that means that you may be having to move negatives from one side of the inequality to the other. Okay, so another important thing for you to know. So let's go ahead. Your first set of your homework will be for you it will say, describe the solution to a system of inequalities. And so what that means is, if your example is, let's say, that was very good, Brace, right there. Y is greater than -3 halves x plus 2, and then here y is greater than -3 halves x plus, or minus 2, sorry, minus 2 here. Then your graph will look a bit like this. Okay, so this first line, well, it won't be quite so shaky. The first line, these are all going to be dotted. The y-intercept is here, and then up 3, back 2 is going to put me around here. Down 3 over 2 is going to put me here. So my dotted line is going to look a lot like this. It's parallel, so because the slopes are the same, we know it's parallel, but the next intercept is down here for this equation, and so we're going to go up 2 over, or up 3 over 2, down 3 over 2, and our dotted line is going to be here, okay? So draw your lines first, and then go ahead and do the shading. So if y is greater than, we shade above. So this one we're shading above. If you're making these lines, remember that if it lands on the line, it does not count because it's dotted. Okay. Here, y is again greater than, so let's use a different color. I am running out of colors, aren't I? And so this is also a solution. Okay, so these are the solutions. All the solutions above this line for this one are true, and all the solutions above this line are true. So the overlapping, what you're going to do, the solution is always going to be the overlapping regions. Okay, so if I take a highlighter, this is the overlapping region right here. Okay, this is the overlapping region. Right here is not. Okay, this is not the solution to the top equation. And so what you would say is, you would say that the solutions, okay, of the system are those of y is greater than -3 halves x plus 2. Okay, so whatever the solutions are of this first equation are the solutions of this equation as well. Okay, so that would be your answer. Let's look at another set of parallel line equations. Let's say that our example is, that's not as good, y is less than -3 halves x plus 2, so the same thing, y is greater than or equal to -3 halves x minus 2. Okay, so we have the same lines here, it seems. Well, similar lines, I guess not the same lines. Let's put the lines in yellow. So this first line is going to be here, the top one, the intercept is 2. It is, again, a dotted line. We went up 3 over 2. Sorry, that's so, but dotted. This one is indicating that it's a solid line, but it's the same line as we had before, but this one is a solid line. This is supposed to be straight. I should be using a straight edge, but I don't have one on here. And it's solid. Now let's look at the solutions. So let's change our color to, let's say, the highlighters, highlight green. So the solution for this one is below the line. So this one is below the line. All of this is the solution for this line. And then here, this is saying that the solution is anything greater than or equal to this. So the solution for this one is anything here. So, okay, as it turns out, our region that is together is between these two lines. This is our only solution region. And so what you would say, your answer would be, I love this color. Your answer would be solutions are all points between the parallel lines and on the solid line. Okay, because you have both a solid line and a dotted line, you do want to distinguish between the two. Okay. Another type of homework problem that you will have is going to ask you to graph the following. Okay, and then tell if a given pair is a solution of the system, and then to also list 3 other solutions. Okay, so this is where your answers are all going to be, this part is where your answers are all going to be very different. So the way that the question would look is y is greater than or equal to 3x, and x plus y is less than or equal to -2. So I need you to remember that I do want you to make sure that you turn this into y equals mx plus b, or y is greater than, in here that's fine, it's done. But this one you would want to move the x over, so you would subtract x, you would get y, and you didn't subtract a negative number, you didn't divide or multiply a negative number, so you don't change the sign. Negative x minus 2. Okay, so now you have your 2 equations. These are the 2. And then actually let's go ahead and go through this. But the other part of this question also would have that is the given pair, ordered pair, a solution. So the blue is all that was given to you. So the question is, it's saying that this is your system, and then is this a solution is the question. And then also list 3 other solutions. So let's go ahead and go to Mathway. I think I'm ad-libbing a little bit here. But now that we have those 2 equations, we're going to go ahead and go to, you can tell what I was doing just a couple minutes ago. It is called mathway.com, graphing. Popped right up for me. And then what you'll do is you will plug in your equation. So y is greater than or equal to 3x is equation number 1. Equation number 2, you solve to b, okay? And so that's why I do need you to have this. Y is less than or equal to negative x minus 2. Okay, and the question is, so where's the overlapping region? So here you had to shade above, here below, and then what's the overlapping region? This is the overlapping region. And so if you think back to the last question, it was, is 0, -5 a solution? So 0 means you don't move anywhere on the x-axis, but then you move down to -5. It is a solution to our second, to this problem, but it is not a solution to both graphs, both equations, and so the answer would be no. And then the last part of this question is to list 3 solutions to it, and so I would say it would be -4, 0. You can go ahead and say -6, 0, -8, 0. You can get tricky, and anything on the line would work. So -2, 0, but that's taking a chance just in case you forgot about the dotted line and the solid line. You could say over here, -6, -4. You really can add anything to this. Okay, so What I would want you to do is I would want you to change it into y equals mx plus b, show me that slope-intercept form, then go ahead and graph it, and then sketch your graph on your homework, and show me kind of the shaded, the joint shaded region. Show me the solution region, and you don't have to necessarily shade this red part and this blue part. You can just shade your joint region, and then I'll compare it to what I have to make sure that you did it right. Okay, so good luck, and I look forward to seeing you in class soon.